Hi everyone. Today I'm covering lesson 1.5 on infinite limits. I think it'd be best to start with an example first. Say we wanted to evaluate a limit like this. Evaluate a function like this. The function is f equals 3 over x minus 2, and it would look something like this. Right, and we can clearly see that at the point 2, x here is approaching positive infinity, and here it is approaching negative infinity. So we can conclude from the graph that limit x approaches 2 minus 3x minus 2 equals negative infinity, and limit x approaches 2 plus 3 over x minus 2 equals positive infinity. But how do we actually get these answers without having to graph the function? Well, we can analyze this here, right? So it's important to go back to what a limit actually is. A limit is just what would happen as a function approaches a certain point. So let's say we take a point that's not at 2, that's like slightly larger, slightly smaller than 2. Here we are approaching from the left, so we can take a value that is slightly smaller than 2, and thus this would be negative. And if 3 is divided by a negative number, a really large negative number, we would get negative infinity. And the same thought process can be applied to here. And we can see that this would be a larger number, and we would get positive infinity here. Now, moving on to some laws that can help us determine an infinite function. Sorry, an infinite limit. So, limit. Let's say a limit is like this: x approaches a 1 over x plus x minus a n. Right? If if n is a positive even integer, then this here would be positive infinity. But if n is a positive odd integer, then limit x approaches a from the right side of this function would be positive infinity, but limit x approaches a from the left side of this function is negative infinity. And there's also another way to evaluate an infinite limit, or rather another kind of expression for an infinite limit. Here I will provide an example. So say we wanted to evaluate this limit: x approaches infinity, right? 2x third minus 5x plus 4. Well, how do we do this? Normally we would plug in, but that would not work in this case. What we could do, however, if we apply the same thought process, is to first take out x the third, and we get negative 2 minus 5, 5 over x squared, and then plus 4 over x cubed. it's important to have x in this position because we can apply the thought process we used to evaluate this here to the problem down here. So now we plug in infinity, right? We would have infinity cubed, uh, negative 2 minus 5 over infinity squared plus 4. This is infinity cubed. Now, if we think about it, right, infinity infinity cubed is still just infinity. And then what's 5 divided by a really, really large number? Well, it gets extremely close to 0. And in this case, we can just think of it as 0 because we are working with massive numbers. And then the same can be said for 4. So here we have, here we would simplify it to this, and then it is just negative infinity because 2 times infinity is just still infinity, but we have a negative sign here. So the answer to this problem would be negative infinity. However, there's still a shortcut to this method. I'll provide an example here. Say if x was approaching negative infinity and we wanted to evaluate this, x squared plus 7, to x plus 5. And we can just take the highest power of the numerator and the denominator. So we would get x approaches negative infinity to x, and then this would be negative 4x squared. And then we can just plug in here. And if we follow the same thought process, of course, we can first simplify. So this would be limit x approaches negative infinity, negative 2x. And if we just plug in negative infinity here, we can easily get positive infinity. And there's actually a definition of a function that can be gained here, and it's as follows: if f has a the function f has a horizontal asymptote at y equals L if either limit x approaches positive infinity at x equals c, or limit f x approaches negative infinity equals c. And I think that's the it for the lesson. Thank you for listening, and I'll see you again.